Hi crocodiles, me again. So as it turns out, I did lose the videos I had recorded yesterday, and unfortunately it means I lost the video of the science experiment I did yesterday. I did it yesterday because you need to freeze water for around 3 hours, so I thought it was better to do it beforehand and show it to you today. However, it could not be possible. No harm done. I'm gonna go through, I'm gonna tell you what I did and why I did it, and I'm gonna do it again, and I'm going to record it again and show the results later. And you can do it with me and we can compare the results and see if you guys are able to do it or if you're not. That can also be a result when we're doing scientific experiments. So the experiments we're doing today are on regards to stalagmites and stalactites, okay? I'm going to say those again. Stalagmites and stalactites. Those are rock formations. They can be rock formations or they can be ice that are mostly found in caves, on the ground, but also underwater in the deepest parts of the ocean. There are two experiments we're going to do. The first one is how is the super cooled water. Now listen to this. Super cooled water, like chilly, icy, not like cool, hey I'm cool, no, just regular super cooled water. There's this theory that says that when water is super cooled, it can be liquid, okay? Even though it's in its almost freezing, it's not ice yet, it's still liquid. If you move it, like I have a water bottle here, if you move your water, even though it's super cold, you're going to see that it's moving, it's liquid. But if that water that is super cool receives an amount of pressure, like when someone hits you, if it receives that amount of pressure, it's going to freeze. Even though it was liquid, you saw it, if you hit it against the table, it's going to freeze. So that's experiment number one. Grab a water bottle, one that you can hit, that's not gonna break, and fill it with water. Put it in the freezer for around 3 hours. Check it every now and then. The one I did yesterday took 2 hours and a half to freeze, and my freezer is in minus 23 degrees. You can check that with your parents. And when I did it, it actually happened. I moved it, I saw that it was super cold, and then I banged it against the table and it froze. So that was a success, complete success. That was super cooled water. The second experiment was the one of forming the stalagmites and the stalactites. The stalagmites are the ones that come from the ground. They're they have like a form of a spine, like a spike that goes from the bottom to the top. Stalagmites with an M, and the stalactite is with a C. Stalactite, C as in the ceiling, and that's where they come from. Okay. So it's stalactite, goes down, and what you need is to have a plate with water, frozen, like ice. So grab one of those plates that are a little curvy on the side so the water won't spill. Put it in the freezer and let it freeze until it's ice, completely ice. And then at the same time, grab a water bottle, just like the one we did before, and leave it again to reach its super cooled temperature. But this time, don't bang it against anything. Leave it liquid, okay? And when you take your plate out of the freezer, you're going to take that water bottle, and the water that's inside is super cool. You're going to pour it down again and there in the ice plate. The theory says that because the water is in its reaching point of super cool and there's ice already on the plate, the ice is going to be a crystallization nucleus, which means that it's going to help, because it's already cold, it's going to help completely form that super cold water into frozen water and become like the stalagmites, okay? That's what should happen. However, I did mine, and guess what? It did not work. It did not work. And it happens, you know, when you're doing experiments and it's part of the scientific method that you can either succeed or you can fail. If you fail, you keep trying, and you're going to learn different things every time you do it. If you succeed, then your hypothesis was correct the first time, which I must say is not what happens every time we have scientific experiments around the world. So I have a theory on why it didn't work. I saw on the video that I'm going to share with you that they used food coloring to paint the water, and they can appreciate better the effects of the super cold water and the stalagmites. I didn't have food coloring, so I thought, I'm going to use paint instead, but not a good idea. I think that because I used regular paint, the water was a little heavier than it's used to be. So that's why when I pour the water down, instead of forming the rock up, it went completely down. That, or maybe it was not in its super cold point. Those are my two theories, but since I lost my videos, I have a new opportunity to keep trying, and I'm going to share them with you. Okay, so have a go, wear your white robes, and let's give it a try. Tell me what you did, tell me what happened, let me know if you did it, if it was fun. Let's share that experience, all right? I'm going to share with you a video that is the one I used to guide me through the experiment, and also I'm going to share a video on stalagmites and stalactites. Have fun. See you.